Hello and welcome to this video about Python sets for data handling. In this video you will learn about the Python set, which is a Python native data storage abstraction, or you could say a native Python data structure. The set provides you with the option to economically store unique labels or objects. These labels or objects will be fixed and are not intended to be changed while the objects are contained within the set. Sets have two main uses within data handling. One as a storage type for unique labels or objects, making the data storage requirements smaller for certain data storage systems. The other use is within algorithms that operate on, for example, data forms with unknown but unique properties, such as unique column or row labels in a spreadsheet. Then the set is a useful holder for column or row labels, or you could say object identities or names. Python's native set class has developed a lot over new Python versions, and more development is expected in the future. So let's take a more detailed look at the set. And the set is a Python data storage type for an unordered collection of unique objects that cannot be changed as long as the object is within the set. This means that set is a collection of unique objects and that it contains objects that can only be one of a kind, and that the stored objects cannot be changed as long as they are contained inside the set. The properties of sets are that sets are mutable, and that is that new elements can be added after the set has been created or defined. So this means that you can increase the size of the set and add new items to the set whenever you want. There is one exception to this, and that is that the set can be made immutable through Python's frozen set function. And that means that the set will be effectively frozen and cannot be changed after the use of Python's frozen set function. Sets are unordered and don't have index numbers inside the set. And this means that there is no function to sort the set's contents using the set itself, and that there is no formalized index function included with the set. The order of the contents inside a set may therefore appear as being random or arbitrary without being either random or arbitrary. Python sets allow for math operations such as the union, intersection, difference, and symmetric difference between two or more Python sets. And this means that it is possible to compute union, intersection, difference, and symmetric differences between two or several Python sets. And this property can be used as one of the many ways to find duplicate objects or similar uses of these math operations. So, the main use of Python set equivalents in older administrative data science code was to economically store labels connected to integer codes. The stored set codes was mainly geographical localities or telephone numbers, postal area codes, state codes, localities, or whatever type of codes you or anyone wanted to use. And this made similar constructions to Python sets very useful in the early era of computing, when RAM memory and storage space was expensive and very constrained, whereas current application storage space often, but not always, grows faster than the need for storage space, for example in cloud computing. At the most basic design level, this design resulted in that 8, 16, or 32-bit integers could replace a string or a number of strings for a data entry. And this was very economical. Currently, however, coders often store entire strings in each data entry, which creates a lot of data handling work due to many different strings representing the same object type, or completely unique string entries may be created, such as, for example, a non-existing unique street address that the post will be delivered to without complaint due to the human capacity of converting the non-existing address to an existing address. Another modern option is the year 2K dictionary object, which can do the same trick by using the integer as a key and the string as a value, while not needing any lookup code attached between the key and the value. The modern dictionary could thus be viewed as a double set or as a set plus a list for every set entry, although it is alleged that Python sets in some versions of Python are implemented using dictionaries. So, Python sets are used in some data science and machine learning algorithms where sets may be used as containers for column or row identities. So you can have sets which are unprocessed and sets or other storage abstractions which are processed. And when an object has been processed, you move it from the unprocessed set into the processed set or other storage abstractions. Similarly, you can have a set of features or columns or rows can be included in the model, and they can be excluded from the model. The columns, features, observations, entries, or rows can be struck from being included in the model or investigated to be included in the model. The math operations that Python currently allows on Python sets can be used to further extend this type of use of Python sets. All right, let's talk a little about how Python creates a set. And Python creates a set by using the curly brackets enclosing objects or items within the set. And another way of creating a set is by using the set constructor. So right, now we're going to make a number of coding examples to show some of the Python set's properties. So start up your code editors because we're going to type some code. All right, having started our code editors, we will start to type some code. And we will begin by describing the code we will type. So we type Python set. And we will start by creating a set named fruits with string fruits objects inside the set. So we type create a set named fruits with named fruit objects strings inside the set. And we will use the curly brackets, and we will use strings as fruit objects. And we will close the curly brackets, and we will print the fruits. And we can print the type of the fruits. So let's run this code. And as you can see, the Python set only accepts unique objects. So here we can see that we have 2 bananas, and 1 banana disappeared because Python doesn't accept duplicates in a set. And similar with the apple. So let's type all duplicates of fruits were automatically removed from the set, and only 1 instance of each fruit object remains. And we can type the objects appear to be random or unordered, but are they random? And we can test this by simply cut and pasting this code. We create a new set of fruits. And what is of interest is this order here. Or you could say this unordered collection of string fruit objects. So let's run this code. And we can conclude that the Python set is unordered, but not random. There is an order to the set under the hood. So all right, now we have shown that the set is unordered, but not random. So now we know that there is an order under the hood, but we cannot see what type of order is implemented currently. And this means that we have to accept that the set is unordered. So all right, let's test some set functions. So let's test to add more fruits to the fruit set with the add function. So we can type add more fruits to the fruit set with the add function. So we type fruits, add a lemon, and we type fruits, add a banana. And we can print the fruits. And this will show that duplicates are removed and that new items are, you could say, added. So here we will display the mutable concept of the set. So let's run this code. And here we can see that the banana was removed as it was already included in the set. But the lemon was added because there was no lemon inside the set. And we can try to add multiple items or objects to a set using the update function. So we type add multiple objects or items to a set with the update function. Or you could say method. So we type fruits, update, and now we can use a list of fruits. So we have a pear, we have a citrus, and we have a peach. And we close the list like this. And we type print fruits. So let's run this code. So here we can see that the pear was added, that the citrus was added, but we already have a peach in this set. So the peach was not added but removed. So we can type the new fruits were added and the duplicates were removed. And now we'll try to copy the set. So we type sets can be copied using the copy function. So we type fruitage equals fruits dot copy. And this will create a shallow copy. We will print fruitage So let's run this code. And we have a copy of the fruit set, and that copy is named fruitage. And now we'll remove objects from the set using the remove function, and we will test the fruitage copy a little. So let's type remove objects from a set using the remove function. Or you could say method. So we type fruitage, remove, and we can remove the citrus. So print fruitage, and we print test fruits. So here we just print a string, and we print the fruits. So let's run this code. And we can conclude that citrus was indeed removed. And we can type that a shallow copy is sufficient for this use. And if it is not, then the alternative is a deep copy. So let's try various ways to reset, clear, or delete a set. So we will clear a set from its object using the clear function. Or you could say method. So we type fruits, clear, and we print the fruits. So let's run this code. And we can see that the fruits set is empty. So here we have a set which is empty. So let's test to delete a set with the delete function. So we type delete a set with the delete function. So we type delete fruits, and we will print the fruits. And we can say that this code will throw an error if fruits have been deleted. So let's run this code. And here we can see that the set is indeed deleted. And this error proves that there is no set or object named fruits. And now we'll loop through the fruitage set. So let's type loop through a set using a for loop and print the contents. So we type for fruits in fruitage, print fruits. And let's run this code. And here we can see that the set is iterable and that we can loop through its contents. And now we'll test some set math operations and show the current way to move an object inside a set into another set. So let's type create an empty basket set and put some fruits in it using set math operations and a mover set. So we begin by creating a mover set like this. And we add an apple to it. We can add a peach and we can add a banana. And we close the set and we print the fruitage to display the content of the fruitage set. And we type basket equals mover set intersection with fruitage. And we type fruitage difference update basket. And we can type that future Python sets may have a one-liner method for moving an object between two sets. And we will print the basket and we will print the fruitage. And we make a little change there. So let's run this code. So here we can see the original fruitage set, and here we can see the new basket set. And we can see the resulting fruitage set after we have moved the peach, the apple, and the banana into the basket set. So this is what we can see from this code. The apple, peach, and the banana was moved from the fruitage set to the basket set with a mat operation method. And this method has the advantage that it works with most objects and not just basic strings, ints, and floats. So even if you have your own designed, you could say giraffe or elephant or donkey object, and you have put it into a set, this set mat operation will work. Whereas some other methods may be constrained to Python native types. And as we stated or typed, in the future, a more proper move object method will likely be designed because this set has been developed at ultra speed since Python 1 and 2, and we expect this development to continue. So right, in this video you learned a lot about sets and how sets can be used for data handling. In the next video we will teach you more, and we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We are excited to have you here, and in this video lecture you will learn about the tuple, which is a Python native data storage abstraction, or you could say native Python data structure. The tuple provides us with the option to economically store labels and objects that are fixed and not intended to be changed. As tuples are defined to not be changed, their properties are easy to predict, and therefore tuples are faster than any other Python data structures. Tuples are important to know for data handling purposes, as tuples are used in a lot of older data science and machine learning applications, programs, libraries, and code, plus are a very common return type for Python libraries. Let's talk some about Python tuples in detail. So now we're going to talk about Python tuples. And tuples are considered to be another type of Python set, mainly used in older Python data science code as a tool for optimizations, speed enhancements for code, and to some degree as a still preferred return object for some important libraries functions. In this video, we include a deep dive into tuples mainly because a lot of machine learning code, libraries, and in particular older machine learning code may use tuples for optimizations and other tuple properties. And this increases the chance, or rather makes it almost certain, that any data scientist or machine learning engineer will encounter tuples in their code or libraries sooner or later. The properties of the Python tuples are that the contents of a tuple are ordered, or you could say indexable, and unchangeable, or as you could say immutable. This means that the new items cannot be added to a tuple once it is created, and that the object items inside the tuple cannot be changed or replaced except through a process of conversion, where the tuple is changed or copied into another object type, and the items are replaced, and the result is changed again into a new tuple, possibly with the same name. If the item objects inside a tuple is of a changeable type and must be changed, they need to be copied in a similar process, changed, and converted back to a tuple object. Structurally, tuples can be considered to be sequences of object items or as unchangeable lists, or you could say arrays with different properties and capabilities than Python's native lists. And we can say that Python tuples are fast and predictable due to these properties. And Python creates a tuple through the use of parentheses enclosing items within the tuple. And you can see some example code on the screen, but now it is time to type some code. So let's open your code editors. And we will open the Jupyter Labs notebook and type some tuple code. All right, having started our code editors, we will start to type some tuple code. So we will type Python tuples. And we will begin by creating some tuples. And here we will show some issues with the tuple. So the first tuple we will create will not be a tuple at all, but something that looks like a tuple but doesn't function as a tuple and is created as a different object than a tuple. So we will type tuple1 equals 1, 2, 3, 4, 5. And we can say that this will return an error if a tuple is expected. So we can print this not a tuple, and we can print the type of this not a tuple. So let's run this code. And here we can see that we created an integer and not a tuple with this code. So now we'll change this code to proper tuple code. So we'll type tuple1 equals 1, 2, 3, 4, 5 and 1. And we will print this tuple, and we will print the type of this tuple. So let's run this code. And here we can see that we have created a proper tuple. Now we will create more tuples. So we will create tuple2 and we will set it to 2 strings, hello and world. We will create tuple 3, and we will set it to a string, hello, and we will create some integers and a world string. And this displays that tuples can hold arbitrary Python objects. And we will create tuple 4, and we will let it contain some integers and some floats. So we have created a tuple with some integers and some floats. And now we will type some code that shows that we can add these tuples together, for example, within a print instruction. We can print tuple 2 plus tuple 3, and we can print tuple 1 plus tuple 4. So let's run this code. And here we can see that we added tuple 2 to tuple 3, and we added tuple 1 to tuple 4. And now we will create some nested tuples. And nested tuples are tuples within tuples. We type create nested tuples, or you could say tuples within tuples. And we can also say that we can create tuples including, for example, named and declared integers, floats, etc. We type float 1 equals 3.91, integer 1 equals 9, and we can set tuple 5 to be equal to float 1, integer 1, and a nested tuple hello world. And we can print tuple 5. So let's run this code. And here we can see that the values of these declared floats and integers were printed, plus the nested tuple. And here we can take a look at how to access the elements of a complex tuple such as tuple 5. So we can begin to type print tuple 5, and the first element of it. And we can continue with this notation. And we can print every element in the tuple. And we can show you how to access the nested tuple. So this line will access the second element of the nested tuple. So let's run this code. And here we can see that the first element, float 1, is 3.91. The second element is integer 1, it is 9. The third element, which we point at with E2, is the nested tuple hello world. And when we add another bracket like this, we can access the second element of the nested tuple. And in this case, this is the string world. And as you can see, this is very useful when it comes to handling tuples. And we can build some more on this knowledge. So we can say that we can access the contents of a tuple by referring to the order of the items inside the tuple, indexed from 0 to the number of items minus 1. So for example, we can take tuple 3 and refer to the first element, and we can print tuple 3 and refer to the third element. And here we have tuple 3's first element and the last element, or the third element. So let's run this code. And here we can see hello and world. Now we will use some advanced functions on our tuples. And we can say that if you feel that this part of the video lecture is tough, complete the Python for data handling section or video course and return to this part afterwards. If this part still feels tough, repeat the course once more and return. And you will feel that with this repetition, this code and this complexity has suddenly become very easy for you, and you will understand this code easily, and everything will be clear with some repetition. So, all right. Let's begin with some native functions which are pre-programmed into Python. And we will begin with the length function. Or you could say method for tuples. So we type print the length of, for example, tuple 2. And we can print the length of tuple 4. And what this function returns is an integer, which will tell us how many items are included inside these referred tuples. So let's run this code. And the printed numbers are 2 and 4. The number of items inside the referred tuples. And we can access the content of tuples as ranges within the tuples using a particular operator. So we can type tuples can be accessed as ranges using the operator type, for example, tuple 4. And this code should access the first two elements of tuple 4. And these are 1 and 4. So let's run this code. And here we can see that we have 1 and 4. And we can use loops to loop tuples. We can type 4 items in tuple 4, print items. So let's run this code. And here we can see that for each and every item in tuple 4, we printed that item. So we have 1, 4, 2.73, and 3.1. We can use the index positions of a tuple and use the length function and loops. We can type for position in a range of the length of, for example, tuple 3. We can print the position plus like this. And pos will be a counter variable between 0 and the range of the length of tuple 3. So the first instruction here will print that integer number, and the second here will print the content of tuple 3 at that position. So let's run this code. And here we can see that at position 0 we have the string hello. At position 1 we have the integer 1, 2, 3, 4, 5. And at the position 2 we have the string world. And now we'll take a look at tuple returns from functions and library functions. And we can say that these returns is one of the main occurrences of tuples in current Python libraries. And the unchangeable property of tuples is one of the main reasons for using tuples as a return item from a function or library. And the secondary reason is the tuples design and predictable size address location, which makes these returns very easy to handle in RAM memory. So we will type tuple returns from functions and library functions is one of the main occurrences of tuples in current Python libraries. Two reasons. unchangeability, and design and predictable size, address, location. Let's take a look at tuple unpacking. Because these tuples, when you receive them as returns, will be, you could say, packed as tuples. And therefore, we will take a look at unpacking these tuples, which is about making proper variables from a tuple. Something which often will be necessary when you consider returns from libraries. So we can type, for example, float 2, integer 2, tuple 6 equals tuple 5. And we can print string float 2 plus a white space plus string integer 2 plus white space plus string tuple 6. Here we will take tuple 5 and unpack it into float 2, integer 2, and tuple 6. And tuple 5 is this nested tuple, which has a float, an integer, and a tuple. So let's run this code. And here you can see that we have unpacked it into the float, an integer, and this tuple. And what we will do now is that we will continue the unpacking further. So we will create string 1, string 2 from tuple 6. And we will print string 1 plus white space plus string 2. And as we have strings, we have no need to cast strings into strings. So let's run this code. And here we can see that we printed the string hello, a white space, and the string world. So here we can see that we have completed the unpacking of these already existing tuples. So what we'll do now is that we will show a custom statistics function with multiple returns. And we will say that Python, as a standard, when you have multiple returns, will always, in its functions, return the returns as a tuple. So this is a pre-programmed standard. So right, let's throw a custom short statistics function with multiple returns. We type define descriptive stats from data, and we can import a library. So we type from statistics import mean, median, and standard deviations. So what we do now is that we make a sort of proper import from the statistics library, because we will borrow some functionality for this custom statistics function in order to display these multiple returns and how they are unpacked. So we type average equals mean data. We type med equals median data. We type standard deviation equals standard deviation of the data. And we return the average, the med, and the standard deviation. What we will do now is that we will print the return of this function. So we will call the function, and we will give it tuple 4. So let's run this code. And here we can see that the function took the data in tuple 4, which we served it, and it returned the average of the data, the median of the data, and the standard deviation of the data. And it returned it as a tuple. So what we will do now is that we will unpack the tuple return. We will type mean, med, standard deviation equals descriptive statistics of tuple 4. And we will print the mean plus white space plus the median plus some white space plus the standard deviation. So let's run this code. And here we can see that the return tuple has been properly unpacked. All right, now we have learned some deep, practical, and very useful knowledge on how to use tuples. And in the next video, we will teach you even more. And we look forward to see you in the next video.